Okay, let's dive right into this. We're about to explore a truly fascinating medical mystery, one that literally revolutionized our entire understanding of human behavior and how our daily routines actually work. Welcome to this explainer. Today, we're unpacking the foundational research laid out in Charles Duhigg's amazing book, The Power of Habit. We're going to get into the precise neurological mechanisms that, well, govern almost everything we do. It's a story that bridges a deeply tragic human illness with some absolutely groundbreaking laboratory science. And honestly, by the time we're done here, you are going to look at your own daily routines in a completely different light.
So, to start us off, I want you to imagine a man whose memory was completely wiped out by a virus. Gone. Yet, miraculously, he could navigate his neighborhood and find the kitchen entirely on autopilot, without actually having any idea where he was. Now, I know that sounds like science fiction, but this is the very real-life case of a man known in medical literature as EP, or Eugene Pauly. At 71 years old, Eugene literally couldn't remember his own son's name. He couldn't recall what day of the week it was. But if he was hungry, he'd just stand up, walk into the kitchen, open the exact right cabinet, and grab a jar of nuts. And the craziest part? If you handed him a piece of paper right then and there, he couldn't even draw a basic map of his own house. So how on earth is that even possible?
Well, the root of this whole puzzle begins with a sudden and honestly terrifying illness. Back in 1992, Eugene contracted viral encephalitis. Now, this is a disease caused by a relatively harmless virus, the kind that usually just gives you cold sores. But in incredibly rare and tragic cases, it can make its way into the brain. And when it did that to Eugene, it ruthlessly chewed right through his medial temporal lobe. He spent 10 days in a coma, teetering close to death. When he finally woke up and the virus had cleared out, his ability to form any new, conscious memories was permanently erased. The specific brain tissue responsible for recalling the past had been completely destroyed, almost with surgical precision.
But here's where things get really weird. Despite this catastrophic brain damage, Eugene's day-to-day life unfolded in a way that utterly baffled everyone around him. One morning, his wife Beverly was absolutely terrified when she realized he had wandered off. She was running up and down the street in a panic, crying, fully convinced he'd walked into traffic. But then, she was stunned to walk back into her house and find him just sitting in the living room watching the History Channel. He had this little pile of pine cones he'd collected sitting on the table, and his fingers were literally sticky with sap. He was totally unaware he had even left the house, let alone that he'd somehow successfully navigated his way back. Beverly quickly realized he was going for these daily walks, collecting little souvenirs, like rocks or even a puppy one time, and always finding his way home without a single conscious memory of the route.
To figure out what was actually happening, renowned memory researcher Dr. Larry Squire stepped in. And Dr. Squire immediately compared Eugene to another famous medical patient, HM, a man who actually had his hippocampus removed in the 1950s to cure seizures. Now, if you looked at their brain scans, both men basically had empty walnut-sized chunks missing from their middle of their heads. But Dr. Squire noticed that while both suffered from this catastrophic memory loss, their actual behaviors were vastly different. Patient HM was so debilitated he had to be institutionalized for life. He couldn't even hold a normal conversation. Eugene, on the other hand, he strangely retained this ability to seamlessly carry out complex daily routines. He lived at home and could chat amiably about the weather or his old days in the aerospace industry. It was like a giant puzzle.
So, to crack this puzzle of Eugene's mysterious navigation skills, researchers had to look at the brain almost like an onion. Stick with me here. If you peel back those outer layers, the ones closest to the scalp, you're looking at our most recent evolutionary additions. This is where all the complex, conscious thought happens. You know, inventing things, laughing at a joke, that sort of thing. But as you travel deeper inside, closer down to the brainstem, you hit these older, much more primitive structures. These inner layers control our basic automatic survival behaviors. We're talking breathing, swallowing, or that startle response you get when someone suddenly jumps out at you. And that brings us to the crucial piece of the puzzle, a tiny, ancient structure nestled right near the center of the skull called the basal ganglia. It's basically this golf ball-sized oval of cells, and it's very similar to what you'd find inside the head of a fish or a reptile or any other mammal. Now, for years, scientists didn't really understand it very well. They mostly just suspected it played a role in diseases like Parkinson's. But here is the massive takeaway for our story. While that virus completely destroyed Eugene's memory centers, his basal ganglia was left entirely intact, unscathed. So researchers started to suspect that this ancient little nub of tissue was the secret to how Eugene was learning new patterns without having a memory.
To understand exactly how the basal ganglia pulls this off, we have to look at some truly groundbreaking research. In the 1990s, actually right around the exact same time Eugene was falling ill, researchers over at MIT were running some fascinating experiments. Fun fact, they kept their laboratories at a chilly 60 degrees just to steady their hands during these incredibly delicate procedures. Anyway, they implanted tiny, microscopic sensors right into the brains of rats and placed them in a T-shaped maze, with a little piece of chocolate waiting at one end. The whole goal was to observe, in minute play-by-play detail, the neurological activity happening as the rats learned to navigate the maze.
Now, as you might guess, initially the whole process was quite chaotic. The rats would hear a loud click, the partition would slide open, and their brains would just absolutely explode with activity. They were furiously processing every single new scent, every sight, every sound. They were frantically scratching at the walls, wandering around until they finally stumbled upon the Holy Grail, that piece of chocolate.
But the data they collected revealed a really dramatic contrast. During the rats' very first run, there was this furious, high-level spike in brain activity. But then, after a week of running that exact same route hundreds of times, the rat's brain literally powered down. The mental activity decreased drastically. The rat didn't need to sniff or scratch anymore. The decision-making and memory centers of the brain simply went quiet. It had internalized that sprint to the chocolate so completely that it hardly needed to think at all.
What those MIT probes essentially revealed was that as the rest of the brain went to sleep, the basal ganglia took over. It does this through a fascinating neurological process known as chunking. Basically, chunking is when the brain converts a sequence of actions into a single automatic routine, and we rely on dozens, if not hundreds, of these behavioral chunks every single day. Whether it's automatically putting toothpaste on your toothbrush in the morning or just going through the motions of making your kids lunch, your basal ganglia is grabbing that grouped sequence of behaviors and just running the whole show entirely on autopilot.
And this brilliantly illustrates the core framework researchers discovered, the three-step habit loop. This loop is exactly what determines when the basal ganglia takes control. First, there's a cue, a trigger that tells your brain to snap into automatic mode and tells it exactly which habit to use. For the rat, it was that loud click. Second, there's the routine, which is the actual behavior unfolding. And finally, there's the reward, the payoff that helps your brain figure out, hey, is this specific loop worth remembering for the future? Over time, the cue and the reward become incredibly intertwined, forging a powerful habit. Because this loop is so deeply ingrained, understanding it is how we take control back. Which brings us to our first actionable daily tip from the source material. Identify the cue. If you ever want to change a habit, you first have to figure out what trigger, maybe it's a specific time of day, an emotion, or a certain place, is sending your brain into that automatic mode.
Think about something as mundane as backing your car out of the driveway. When you first learned to drive, this required a massive dose of concentration, right? You had to calculate mirror reflections, estimate the distance of the garbage cans, monitor for traffic, ease off the brake. It's an incredibly intricate ballet of actions. But today, you do it effortlessly. You might even be yelling at your kids in the back seat while you do it. You can do this because your basal ganglia recognizes the car key as a cue, pulls up the chunk driving program, and runs the entire routine on autopilot. And this brings us to our second actionable tip: isolate the routine. Once you actually know your cue, you have to consciously interrupt the automatic behavior that follows it. You can't just delete a bad habit, but you absolutely can swap out the routine for a better one.
Now, you might be wondering, why does our biology even work this way? Well, ultimately, our brains are constantly seeking to save energy. Left to its own devices, the brain will try to make almost any routine into a habit. And this effort-saving instinct gives us a massive evolutionary advantage. Think about it. An efficient brain requires less room, which means a smaller head, which actually makes childbirth easier. Pretty wild, right? But more importantly, it allows us to stop thinking about basic survival behaviors, which frees up mental capacity so we can invent spears, or build airplanes, or design complex video games. But because our brains are so desperate to save energy, they fiercely guard these habit loops just to get the payoff. And that leads to our third actionable tip. Experiment with the reward. If you have a bad habit of eating junk food at 3 p.m., ask yourself, is your brain actually craving sugar? Or is it just craving a break from work? If you change the reward, you can literally hack the entire loop.
So bringing it all back to Eugene Pauly, he could find his way home or locate that jar of nuts in the kitchen because his basal ganglia was flawlessly running habit loops. These were triggered by subtle cues in his environment, completely independent of any conscious memory. And for us, by identifying our cues, isolating our routines, and experimenting with our rewards, we can take the steering wheel back from our own basal ganglia. As we marvel at how Eugene navigated his world completely on autopilot, it leaves us with a rather profound question to consider. If your brain is constantly seeking to power down and hand the steering wheel over to the basal ganglia, what invisible cues and hidden routines are secretly running your day right now?